So welcome to y'all today. Hopefully y'all having a good day so far. It's our last class of the day, so let's try to wrap this up. I know some of you have to leave for medical reason or other things. Hopefully you guys are able to access the link I just posted on the side. Please be respectful of the class environment. As I said, there's zero tolerance for messing around, but please participate in any other way. Friendliness is fine. Okay. So today's lesson is just wrapping up of what you should have written down in your notebook already. I know some of you did, some of you have not. If you haven't done so, please do so. It is good to not fall behind this week. I'm a little bit more tolerant of people turning in things late or so on, but please don't turn in something that's blank because that's a waste of your time and my time. It's being very childish and immature, but please turn in something that's productive. Okay. Next, if you have a scratch piece of paper or just try to keep track of things in your head, is fine. I'm going to ask you to put down a few things in the chat. If you don't have a scratch piece of paper, that's fine. So let's begin. So, class for this week, as well as part of next week, will be on the scientific method. The scientific method sounds like it's something really complicated. It's not. It's a way of understanding something by being aware of it and then learning how to use it, basically. Okay? AKA living life. So the goal of any scientific method most of the time is to solve a problem. Hey, we're gonna run out of oil in about 35 or 40 years. Can we make cars that doesn't run on gas and oil, aka electric car, right? A lot of gas and oil are causing pollution. Can we get electricity that's made in a clean way instead of burning coal, gas, and oil, solar panel, and so on? So observation is just being aware of things. Any one of you who have good awareness of your surrounding is an observant person. The most famous of which is probably Sherlock Holmes, which is a fictional character. But he is able to solve crime and understand things very well by just first being aware of it. So once again, observation is just you being aware of things directly. You notice the smell of certain food in the restaurant don't smell right. It might be bad. Okay. You notice how tall someone is or the size of your shoes. You're measuring it using tool or you look at numbers on the shoes. Last but not least, after you being aware of something, you ask a question about it so you can understand it. That's called being curious. And once you're curious about something, you want to figure it out. That's called making a prediction about it. The first step of figuring it out is called a hypothesis. So a hypothesis is simply a guess or good prediction. It's not a random guess. If I predicted, for example, Pedro is going to be a famous comedian who's going to win American Got Talent, that's not a hypothesis. That's a random guess that has nothing to do with it. But if I guess that Pedro will be successful in high school if he focused and he's going to graduate high school in 4 years or so, that's going to be a reasonable guess. Okay, that's based on something. A guess is always testable. So if I made that prediction in 4 years, if Pedro graduate high school with honor and his family is happy, I was proven to be right. If he didn't, then I was proven to be wrong. A hypothesis can be right, wrong, or partially right. And a hypothesis usually starts with the if, and in the middle of it has the then. It's based on real life because if you do something, then there's a consequence. If you're going to be mature and focused, you're going to be building better relationship and earning people respect. If you are a good business owner who treat their employer right, then your company will be more productive and so on. So here's an example of that whole process. So last Thursday, after I met with some of you guys, other class, I went fishing at around 3:15. I got to a spot. I first walked around up and down the shore for about a minute, and I noticed this spot right here. Please look at it. Tell me what you see in the chat. So go ahead and take a 20-second analysis of this picture and tell me not what is being pointed by the arrow, but every detail that you can see as a fisherman. So let me go into the chat. Tadpole, mud, okay, minnows, anything else? So let me go back to the picture again. Grass. Okay, very good. Every detail that you can see. Imagine you're like a detective and you're solving a crime. Every detail matters. Okay, so first I was aware that there were minnows swimming around, or some of you might guess it was a tadpole. Second thing, I did notice that the water was somewhat clear, but not super clear, right? We can see the minnow, but if you guys notice on the outside of that picture over here, it is not clear enough for me to see things in 3 or 4 feet of water. So this goes flat and it drops at a steep angle down. So from that, I am able to make some question. Is this spot a good spot for me to fish? That's my scientific question, right? Because I see bait there, and bigger fish eat smaller fish. So my next thing is I'm going to have a hypothesis. So my hypothesis is if I were to use bait that looks like a little minnow, and I swim it from deep to shallow, imitating a scare or a bait fish that's running away, then I can catch a fish. So I summarize it as if I use that bait that looks similar to a fish and throw it in the area where I see the bait fish, then I can catch a fish. I don't need any explanation. A hypothesis has no explanation. It's just if there's an action, then there's a consequence. Okay? So then, of course, I put on a bait that looks similar to the bait fish. I throw in that area. Obviously, it takes time for me to activate a fish to see if it works. So one time doesn't work like anything else in real life. Real skill takes some time to do. So I threw that bait in that area for about 4 or 5 minutes, and about 6 minutes in on cast number 15, when I was popping my bait pretty fast, imitating a scare bait fish, I was able to catch a small walleye. So the test was me doing the fishing. Obviously, test takes time, and I was able to catch the fish. I want you guys to notice that this is a real picture and not some fake picture I just download, because here you see the grass with a nice 90-degree angle, and this is the same grass right there with the nice and 90-degree angle. Now, I went and reused that process to try to improve upon things. People made cars over 100 years ago, but you guys know that cars now are way better than cars back then. So what's the next thing I tweaked? I tweaked a different bait that had a little bit more color at the end of it, just to, when it's in the muddy water, it attracts. So I took a Sharpie like marker that's yellow chartreuse, and I painted the tail of the minnow a little bit. And of course, after about 4 or 5 minutes of fishing with that new bait, I was able to activate or trigger another fish to bite. And so here's the video. Oops, sorry. Sorry, my internet is slow. My mom is using it. And just to prove to you guys see that little grass that's that nice and 90-degree again. And if we can zoom in or somehow show it in more detail, you can see the bait fish moving around. So those tiny little black spots are those minnows swimming around right there. So as you guys can see, I don't just use the scientific method for science. I use it for real life. I use it when I game. I use it when I go shopping. I use it all the time. It simply means being aware of things. Okay, so I'm going to pause my video. So once again, our observation is you notice that one group of students who are walking and one group of students who are running have different amount of wetness. So your hypothesis has to be based on your observation. So a lot of these hypotheses are very good. If you ran, aka speed, then you would get less wet. If you run in the rain, then it could affect how wet you. So this hypothesis here could be modified. You need a if then, right? So if you run in the rain, then you might get wetter or drier. So if you were running, you would get, once again, remember the then, if then. If I run in the rain, I would probably get wet. If you run in the rain, then you will get more wet. So this is a very good hypothesis here for us to learn from each other. If you run in the rain, then you will get less wet. This is also very, very good. Okay, so make sure you know it's based on your hypothesis and it has a then. So that's why no judgment is here for us to give feedback on each other. Now this one is a hypothesis that is a little off. If they were running, then they will get wetter or drier. Get home faster has nothing to do with that observation. Okay? So here, as I say, don't get upset at me. I'm giving you feedback. Make sure you focus when you do something. So that one is a little off, but at least you're trying, so that way I can give you feedback versus someone who didn't do anything at all. If they walked, then the water would hit them, and they would likely then they would run. Okay, that's still fine. If they walk slower, then they will get wetter. So once again, that's a good observation. Very, very straightforward, and it leads to a good hypothesis. Okay, if you run or jog, then your shoes will pick up less water. Okay, that could work because your shoes is part of your wetness, so that's perfectly fine. Okay. So with that, hopefully everyone here would get the idea that it has to be if an action, then a consequence. But the consequence has to be related to your observation. So getting home faster has nothing to do with your observation. Okay? And you're not able to predict that or test that in a way related to your observation because I'm not following them home. That'd be kind of creepy if I'm following kids home, right? So that it has nothing to do with the observation. I can only see which one looks wetter and which one looks drier. So the data can prove that. So I'll give you guys one last example of real life. So several years ago, when the Xbox One came out and the Xbox 360 were becoming discontinued, I was grocery shopping with my mom at Costco. She doesn't speak any English, so I have to help her out. And I noticed this was sitting on the shelf. I haven't touched it since then. It was quite dusty already. You guys see the dust? So someone must have forgot to put it on the shelf to sell. So it was discontinued because the new Xbox already came out for about a month. I bought it at $100. Clearly, because I have a hypothesis. I predict that there's a lot of people out there who are Xbox and PlayStation collectible fan. And that means because it's brand new, it's mint condition, the price might go up. So let me just quickly Google the price for you right now on Amazon. I have not done this. Xbox 360 Gears of War edition. So remember, I bought that for $100. Okay. If you guys look at the screen right now, if you buy used, let's see how much is used. If it's used, is $125 acceptable, and if it's brand new, the price is so as you guys can see, by being aware of the fact that a lot of people like to play video game, right? Me included. I bought that for $100. Now, obviously, $100 then now would be worth like $120. But was it a good prediction? Was it a good hypothesis? If I buy it for $100, I might have a collectible, or then I can have a collectible that will be worth more. Obviously, the price is testable. You can look it up on Amazon or eBay. I think selling new is like $400 or $500, which is enough for me to buy the new Xbox X coming out next month already. So that shows you an example of observation leads to a benefit. The more observant you are in real life and the more focused, the better it is. And with that, we'll wrap up for today. Peace out, and I'll see you all on Friday, okay? Hopefully, you all have a good day. Enjoy the rest of the day today. It's nice.